Hi everybody, I hope this finds you doing well. I want to show some enhancements to Illuminated Cloud support for Apex unit testing and code coverage analysis. The general theme here is going to be using dependency graph analysis in order to do two things. To make unit testing more reliable and accurate by making sure that the org is up to date and reflects the local project state before tests execute. And also to make it so that as you are working on changes, enhancements, whatever it happens to be, to a subset of your code base, that you can focus on that specific subset and still get good, reliable, useful test execution and code coverage analysis, again, based on an analysis of what's changed and its dependence and or dependencies. This will make more sense as I go through, and I think the best way to go through the demo is just to build up kind of step by step. There will be about 4 different layers to these changes, and they build on one another, and hopefully at the end we'll kind of review and show how it should tell a nice story about how it improves the overall process, the overall experience of developing Apex and writing tests, verifying that, and then making sure that via code coverage that you have actually written sufficient tests to exercise that logic. So why don't we go into the application level settings for Illuminated Cloud and look at some of the new options that have been added. We're going to start with this one right here, deploy before running unit tests. It pretty much does what it says, so I imagine you can infer the general meaning, but it effectively means let's make sure that any changes we've made in the local project are reflected in the organization before we execute unit tests. I think we've all had this experience, maybe more times than we prefer, where we make kind of a sweeping set of changes and then we are going to run the tests to verify those changes, and we may not deploy everything that needs to be deployed. And best case scenario, we know about it immediately because we get unexpected failures because there's basically a mismatch between the tests and the tested code. But worst case scenario, everything seems to go by and the tests run and execute just fine. And there was a lurking bug, but you didn't see it because all the changes weren't deployed, and you don't see that until later, potentially when you're trying to put the changes into a downstream environment like production or into a CI/CD environment. So hopefully this type of automatically bringing the org up to date, this type of feature will help to mitigate those types of problems. Now, a couple of qualifications on it. It is disabled by default. The reason is that there is a cost to deploying before running tests. It's a requisite cost, but we'll show where it may be more than it needs to be. But one way or the other, the org needs to be brought up to date for the test to reflect reality. But there is a cost to it, and it is different from what has come before. It's a behavioral change from all the way back when Apex unit testing was integrated. So I try not to put surprise updates that could have a cost associated with them. Now, for most people, I think you'll want to enable this. I'm going to talk about the 2 kind of classes of exceptions where you may not want this enabled as we go through, and it'll make sense in context. But for now, let's go ahead and accept this, and let's go ahead and go into a test class. And by the way, I have the presentation assistant plugin enabled or feature enabled. So you're going to see the keystrokes that I'm using at the bottom of the screen for Windows, Linux, and for Mac. So if you want to know how I did something, it should be shown at the bottom of the screen. So I'm going to run this test suite using a context configuration, just Alt-Enter for me, Opt-Enter on the Mac. I'm going to go ahead and run this, and let's just kind of see what happens and how it compares to what came before. So the first thing you'll notice is it just did basically a deploy modified metadata. Now you can see it said that all files are up to date, but let's look at what was written to the console here. So it said it was going to deploy requested test classes, which would just be this one class in this case, and their dependencies. We'll come back to that in a moment before executing unit tests. And it said it found 25 files. Now, I only asked it to do something with 1, so we'll look in a moment where that 25 comes from. And it also said because it's incremental deployment, it's only going to do out-of-date files. As you saw, everything was up to date, so there was nothing to do. So it ran the tests and everything passed fine. So let's first start with this notion of dependencies. So by dependencies, it means everything that this test class and its test methods depend on, but everything that they depend on as well, transitive dependencies. So what were those transitive dependencies? How do we get from 1 file where we started to 25? I think the best way to show that is to show what the behavior is if you're using something where it can't do an incremental deployment. So I'm going to enable conflict detection on this connection, and I'm going to say for shared logins. Now, I'm not going to go into a lot of detail here, but at a high level, I would just say that the reason that you can see that deploy modified metadata, the action's gone, the reason that that's disabled automatically when you turn on shared login conflict detection is that the same local versus server comparisons that are used for incremental deployment are also used for shared login conflict detection, except it's the opposite logic. Instead of saying, is the local newer than the server, it's asking, is the server, has it changed by any user since the last time that things have changed, or since the last time we've retrieved or deployed locally. And so you can't have both of those operating because one needs to win out. And in this case, conflict detection is very important to make sure there's no loss of work, no loss of data. So when we do this exact same thing, I'm just going to rerun that test suite, we can see the same type of behavior, but instead of saying out of date only, it now says deploying 25 files, and we actually see a deployment taking place. We didn't change anything new. There's nothing that's newly out of date. It's just having to bring the org up to date based upon the fact that it can't do an incremental deployment. Now, it is going to select the smallest subset of files that it can based on the test you're trying to run in their transitive dependencies. So let's look at those transitive dependencies and how it arrived at that. Okay, so we can see some classes, we can see some labels. Notice it said 38 up here, even though it said 25 files. That's because some of these components exist in the same file, like custom labels. So we see several classes, we see custom labels, we can see objects, decomposed source format, custom objects in their fields, validation rules, things like that. We can see a couple of visual force pages. I know that's dated, but it helps to drive the point home because we can have static references in Apex to those, and static resources. And so where do those come from? Well, some of them come from directly within the original test class, like this class that's being referenced here is also included in the deployment. We can see that we are using the Apex proxy effectively for the shopping list custom object, and we can see down here for some of its fields, like items and ID and things like that. So we can see how those got pulled in. The visual force page was pulled in by a compile time constant for that page reference, so shopping list mobile list. One of them was pulled in. Let's navigate to that. So this also has some compile time constants in it. So we can see here, here's how one of the static resources was pulled. In this case, it's a resource bundle, but we can see how it was pulled in. We can see, for example, how other pages were pulled in. Excuse me. We can see some custom labels that were pulled in. So that's how our custom labels were pulled in and deployed. So we can see how this kind of transitive dependency analysis pulled things in. So now let's talk about the two times that you might not be able to get the best benefit from this. Well, one of them is what we said earlier. If you are using conflict detection for shared logins, it has to deploy everything that it detects as part of the required transitive dependencies in order to make sure everything's up to date. And if you are, say, running all tests for the project, it may look at that and decide it has to deploy everything and you only have 2 modified files. In that case, it's going to be inefficient for you. And so you'll have to bring the org up to date yourself. Apologies, that's just the best I can do. If you are not using shared login conflict detection, then bringing things up to date via incremental deployment, whether that's via Illuminated Cloud doing its own server to a project comparison, or whether that's using a source tracked organization like a Scratch org or a source track sandbox, and the CLI using source tracking metadata, it should be very efficient. Those are times when it would make sense to turn it on. But the other time that you wouldn't necessarily get a benefit from it is if you're using dynamic references. You know, I've already mentioned here that we're using static references. Here's a static reference to a label. Here's a static reference to an S object. We mentioned static references over here to S objects, to other types, like this one, to fields, things like that. You can also have static references to flow via flow interview types, to data weave scripts. If you are using those, you're good. If you're having to use, excuse me, dynamic references, type.forName,sobject type.get to get a field by like a string variable. You're going to begin to lose benefit here because there's no way for Illuminated Cloud to understand what the actual targets of those references are. They're not actually defined or resolved until runtime. So if you can convert those dynamic references into static references, that's great. Do that, you'll get this benefit. But if you're implementing something that is truly dynamic in nature and based on dynamic references, you may get diminishing returns on the ability to use this and the other features I'm going to show. So those may be times that you just want to turn this off and be responsible for bringing things up to date yourself, or as you'll see in a moment, for doing dependence analysis yourself. But hopefully this makes sense that it can use this metadata and the cross-reference relationships to figure out what to do, and it can basically bring the org up to date and make sure that by the time you're executing unit tests that you are executing them in a coherent environment. And let's put that to the test. Let's take something that is maybe a very indirect relationship like this validation rule, and let's make a change to it. So why don't we negate the logic in this validation rule and change it to not is null, and we'll rerun those tests. So we're going to see here that it has to deploy. And actually, I meant to turn off incremental deployment. Turn back on incremental deployment there. I'll do that in just a moment. We'll see the benefit of that on the second deployment. So in this case, it did have to deploy 38 components because I made a change to something that wasn't modified previously. But we can see that by changing that, it brought things up to date and it ran tests. And of course, now we see failures. And if we look at the failures, we can see that they are field custom validation exception, which is what we'd expect. Now let's talk for a second about the fact that we see some failures and some things passing. The 3 that passed, why did they pass? I just did something that should have broken them. Well, the fact is this is doing dependencies analysis. It is not doing data flow analysis. So it doesn't know if some of these things that some of these tests, for example, may not actually exercise this particular validation rule, or if you have a method, and we'll show this later, may not actually call that method because there's conditional branching logic in that test. So it's going to run everything that it needs to based upon dependencies analysis. It's going to deploy everything it needs to based on dependencies analysis, but it's not necessary. It may deploy some superfluous things based on if it had every bit of information about how the logic proceeds at runtime. There may be some code paths that bypass the things that cause issues. Okay, so let's turn off shared login conflict detection so that we can have incremental deployment, and let's now make a change that will cause a failure. So we'll just go ahead and do that, and we will go ahead and deploy. I keep hitting the wrong thing. Here we go. We'll go ahead and rerun that unit test. It'll do a deployment. Now it says again out of date only. It's only going to deploy one thing this time, and so it deployed one thing and it failed. So if that failed, do we want to run tests? Well, the org is not representative of the local project state. I think it'd be a waste of time to run tests because we really don't know to what extent passes and fails with the test reflect what we're actually aiming for. So we'll go ahead and just short circuit the whole thing. So it will allow you to short circuit the whole process. If you kind of feel like, well, I saw what failed, I'm going to go ahead and allow them to run, you can go ahead and do that. It will give the option, but most of the time you're just going to want to stop it and short circuit it there. So let's go ahead and revert that change, and we'll go ahead and rerun one more time. And again, there's going to be an incremental deployment, and it is going to bring the org up to date for that one validation rule. We can see it just happened, run the test, and everything should pass. So we're back into a good state. Great. Okay, so that was the first thing I wanted to show. Let's move on to the second thing I wanted to show, the next enhancement. So for that, why don't we go to, say, container or collection util. Okay, so we have this method is empty, and it's used quite broadly. It basically says if you pass me a collection in the form of a list, a set, or an iterable, if you pass it to me, I will tell you whether it's empty or not. It's empty if it's a null value, so it's null safe, or it's empty if it has no elements. And so that's the logic here. So let's say that we are going to make changes to it. We will in just a moment. And we want to do a regression test on the changes we've made. We just want to make sure that all the tests that passed before pass after I make my changes. Well, you may notice that even though I'm in a non-test class, there is a difference. There is now a run icon, a run action in the gutter, and it looks different than what we see for unit tests. It says run dependent tests, whereas if we go over to unit tests, it just says run tests. So for this, run a single test, or for a class, run multiple tests. Here it is run the dependence of this. Now I've been talking about dependencies, which says what are, I'm a test class. What are all the things I depend on, and get the graph of that. Dependent analysis goes the other direction. What are the things that depend on me? Think of it this way. If I'm looking at dependencies, think of navigating in, Control B or Command B. For dependencies, think of find usages. Okay, so it's the two different ways of traversing the relationship. And so in this case, for dependence, we're going to get the recursive find usages until we reach closure, the transitive dependence. So let's go ahead and say that we want to run dependence of this method. So it's going to go out, and you can actually see it finding. You saw multiple iterations there as it found the transitive dependence, and it found them in several different tests. 5 different test suites here in several different methods. And it is important to say that it is doing method level dependent analysis here. So it found 30 transitive tests that ultimately will go through is empty. But if we look at is not empty, that actually has less usage. So if we do the same thing with it, we should see less transitive tests. So we see 19. So, 2/3 effectively. So it is a method level analysis, which means that doing this type of regression testing should be very efficient. It's only going to run the things that it absolutely needs to run. Again, to some extent, not take into account control flow analysis or code or data flow analysis. And in fact, again, let's put that to the test. Let's go ahead and take out this null check. And let's say we want to run all the dependents of this again. And so again, it's going out and looking for all the dependents, should be the same number. You see it has to do a deployment now. It has to deploy this one class that I just fixed or that I just modified. So we're now seeing this layering of these changes, and now it's running the test, and now we are seeing failures. So we see 17 failed, 13 passed. So again, the 13 that passed either had conditional logic that didn't call this, even though they could, the conditional logic didn't, or perhaps they called it always with a non-null value, in which case not doing that null check was irrelevant for those tests. So we can see that that actually gives us a very tight way to do, effectively validation of the changes that we're making, narrow validation of the changes we're making. So we'll revert that and go ahead and do that one more time and make sure that everything's back the way that it should be. And then I'm going to show you one other thing real quick here, and that is what happens if there are no dependents. So this completes and 100% success. And now let's go up here and we have this private constructor. This is a best practice when you have a pure utility class, is you make it so it's not constructible externally. Same thing with singletons and factories and things like that. Generally, you've got a private constructor for some reason. And if I say run dependents of that, now there could be internal calls to that constructor. There aren't, but if there were, then it would find those as dependents. But in this case, there are no dependents. And so it just tells you very clearly, there's really nothing for me to execute here. I can't resolve back to any Apex unit tests. Okay, so this is wonderful. We now have the ability to bring the org up to date based upon change files before we run tests, and we have the ability to do very focused regression testing for the system under test, for modifications of system under test at the type level, the product type level, and at the product kind of executable member level. So I mean like constructors, concrete methods, properties that have getters and setters, getters and or setters with logic. You can have this ability to execute on it. And by the way, if you don't like these, if you don't want these in the gutter, if they're noisy, not in non-test classes, you can turn those off here. They're on by default, but I can turn them off, and you can see that they just go away at both levels, and they're still available on your test classes, and you can still access them if you want by right-clicking and say run dependents, but they don't necessarily create noise in the gutter. I personally think you're going to want them. I think they're very, very useful, but you can turn them off if you want. So I'm going to reactivate them. So let's say we want to do this type of regression test on a broader scale, say the whole project based on everything that's changed. Well, that's also available. This is the third thing I wanted to show. So here are some unit test run configurations I've created. So here's the good old all tests that would execute all tests. You don't have to check anything. It's just going to find all the unit tests and their methods, and it's going to execute them when you run this. But notice that there's a new option on it called changed only. And as the tooltip says, effectively it says when this test run configuration executes and that's checked, it is only going to include the subset of tests that are considered changed or that exercise change code. So those are two different things. So if you have a unit test class that is changed, and by changed I mean relative to version control, I'll circle back around to that in a second, but a unit test class that's changed, that will be executed. If you have product class, it will find all the unit that is modified, so like we just changed is empty there. If you have that changed, it will find all the unit tests that exercise that, and even if they're not modified, they'll be executed. The point is whatever your modifications are, it's going to run all the tests to exercise those modifications. Now, when I said relative to version control, if your project's not hooked up to version control, you can check this if you want. It's irrelevant. It's still going to run it as if that were unchecked. It's still going to run all tests under the kind of definition of that unit test run configuration. So in this case, all tests, if you had an all tests under a particular directory, then all the tests under that directory. But if it's hooked up to version control, again, it's going to filter for tests under that directory for change files. If you have Salesforce Test Suite XML files, then you can create run configurations from those and have those only exercise changed only. If you have an ad hoc selection, you can do the same thing. In this case, just two specific test classes that are for a specific kind of category or subset of my tests, maybe a particular feature. There are a couple of places where it doesn't make sense to run changed only though, and that's where you're explicitly wanting tests to run. So if I go out and do a unit test context configuration, I say, I want to run this specific test method or all the test methods in this specific class, you don't want it to come back and say, well, nothing's modified. I'm not going to run anything for you. You've just explicitly asked it to run those. So you can see that there is no option on a unit test context configuration or similar on dependence. And in fact, this one, the common use case here is I've just modified product logic, and I want to make sure that those modifications haven't introduced regression. So go run all the tests that would exercise this change product logic, and none of those tests may be modified because they shouldn't have to be modified. I shouldn't have introduced any behavioral changes. I've just enhanced it or made it perform better or fixed a bug that wasn't identified by my unit tests. So this is another one where changed only has no relevance. But let's see what happens when I run one of these. Okay, I'm going to go over here and I'm going to say run all tests with changed only on. So it's running. And you can see that it tried to do an incremental deployment, again, building on everything, tried to do an incremental deployment. And you can see that it ran a pretty small subset of tests, only 11 tests. And because of the changed files relative to version control in this particular project, excuse me, those are the only tests that needed to be run to exercise the change logic, whether it was change test logic or change product logic. Okay, so let's put that to the test. Let's go here to collection util, and let's say modify that. And let's rerun that. Let's rerun that and see if it changes anything. It certainly took a little bit longer to find all the dependents. And it's now deploying that change. I just changed one of my product classes. And now it's running 57 tests. So, it went up from 11 to 57 just by virtue of me beginning to make changes in my classes, whether they're test classes or whether they're product classes. And if I revert that and we do the same thing, then it should go back to just the 11. So it is tracking that. It is taking that into account. So this becomes a really great way for you to set up a large-scale test suite, all tests being kind of the extreme, and say changed only, and begin making a bunch of changes in your code base and execute exactly the tests that need to be executed in order to make sure that you're not breaking things and have a really nice cycle. By the way, what happens if you run tests for something where nothing's modified? We actually have an example of that. Let's go try to do this. It says that there are no, it's not modified nor are its dependents. So what do you want to do? Well, you just asked me to run these tests. So do you want to go ahead and run all of them, or do you just want to call it a day and say, if nothing's modified, there's nothing new to do? And you can also say, don't ask again, and whichever decision you make here will become the new policy. So we'll go ahead and ask it to run all tests, and it'll run all tests. So there's nothing to bring up to date. It's just going to run all the tests there. If we go and run it again, I can say no, and you can see that it says nothing was found. If I run it again and say, I want you to always go ahead and run all tests, it will tell us, okay, well, you can always change this setting back if you want here, and it'll go and run the tests. And while the tests are running, I'll show that to you. Right under default to changed only, we can see that policy here. And we just changed it from the default of prompt the user to run all tests. So we'll go ahead and change it back to prompt the user. And if we go back over here and do it again, we'll get a prompt again. So you get the idea. So that makes it so that, well, if you try to run tests and nothing's modified, but you still want to know what the output of those tests looks like, it'll prompt you by default. Okay, so now we can bring the org up to date. We can do both very focused and broader regression tests based on a particular area of interest. That was kind of the run dependence, or based on the entire project or some subset of the project, and filtering by changed only. So we're getting closer to being really focused on what we're working on, but the one thing we haven't touched on yet is code coverage. Do we get these same benefits for code coverage analysis? And the answer, of course, is yes. So we'll run our all tests again, but this time let's run it for coverage. And so it's going to go, nothing should need to be deployed in this case. It's going to run the same 11 tests, and let's see what happens when it finishes and it shows us the coverage. So a couple things you may notice immediately. One is this is not all the classes in this project. There are, I don't know, 100, 200 classes in this project. So this is not all the classes in this project. So it's also showing changed only kind of parenthetically here. So what's going on here? Well, there's a filter, and you can turn it off. You can see the original view, everything. But at this point, we're trying to focus on things that are different from what they were before. I don't necessarily need to analyze things that are unchanged. So it's giving the same type of focused view that just the overall changed only test execution is. And so it is showing things that are modified. Things that are blue here are annotated as modified. Things that are green are added. Notice there are a couple of things that are black, meaning they're unchanged, but they have a little parenthetical as well saying, while these product classes weren't changed, tests that exercise them were modified. So we're going to go ahead and show you some the coverage on these. And in fact, we have one here that's at 50%. That's not very good. Let's watch how things will evolve as we continue to work in our code base. So we're going to open that up and we can see our coverage clearly displayed here. And we can see that this whole method is uncovered. So let's see if we can fix that. So I'm going to use goToRelated and I'm going to go to the unit test for this. And I can see that I've written tests for the constructors, but I haven't written a test, kind of, for add shopping list. Well, let's go ahead and write one real quick. Boom, done. All right, well, let's rerun that test execution. So rerun all tests with coverage. And it's going to deploy that one test class where I just enhanced it. It's going to run all the tests that it needs to run based on what's modified. Now I could have, if I wanted, I could just run the dependence of this or run this test for coverage. But this is giving us the ability to make sure the whole project in terms of what's modified is kept up to date. And we can see that on the fly, we now have 100% coverage in that same class. So we're in good shape there. So the point is it's very quickly allowing you to cycle on making modifications to tests and product, deploy those, only the things that need to be deployed, run only the tests that need to be run to exercise the modified logic, and view the coverage of only the things that have been modified. I think that's what we were looking for. So that's great. Like I said, the outliers are if you're using a lot of dynamic references and or the deployment's too expensive because you're using shared logins and you can't do an incremental deployment. Okay, so a couple of things real quick. One, there are two gaps here. Those gaps are, and I plan to address them very quickly. One of them is when it does this changed only analysis, the changed only analysis is at the granularity of a file. Is this file modified in version control? I want to make it so that if you change a method or a member or something like that, that when it goes to find the dependents, just like it does for dependent analysis I showed you earlier, it will do everything at the method or member level so that it will not have to run, for example, all of authorization util test. It can only run the part of authorization util test that matters for this subset of authorization util that's changed, or things that call authorization util, or I'm sorry, things that it calls. The second part is if you modified, say, that validation rule and you do this type of kind of all tests, changed only testing, it won't pick that up. I need to back out from, it only does Apex class, whether they're test or not, I'm sorry, Apex type, whether they're classes, test classes or triggers, classes, enums, interfaces. It only uses those for its analysis. I need to back out from direct and indirect references to other changed metadata types. I'm planning to do this almost immediately, but there may be a small gap there until I do. Once that's done, it should close that gap, the known gap, to almost zero, again, assuming static dependencies. Now, having said all of that, I do recommend that you truly run all tests in your local project before you go and say submit this for a pull request and run it through a CI/CD process or try to push it into a production environment. If you see behavioral differences there, things failing that didn't fail when you did this locally, ideally let me know about that with a reproducible standalone test case, and I will try to address what I can there. My goal is to get to as close to 100% reliability and accuracy in terms of this dependency and dependence analysis. I already identified the gaps I said a moment ago. I'm going to close those. There may be others. Let me know about them. If you see it running more tests than it should, it's finding more dependencies or dependents than it should, let me know about that. If you see it missing some, that's even more important. I'd rather err on the side of doing too much than missing things and not being accurate or reliable. Okay, so having said all that, I hope you find this useful. I hope it increases your overall kind of development cycle velocity. I hate to use that term, but I think that's really the most appropriate term. But it shortens your development cycle, wash, rinse, repeat cycle significantly by allowing you to focus on exactly what you're working on. Let me know what you think. Positive, negative, kind of let me know. Otherwise, thank you very much for your time. I know this was a long one, but I appreciate your patience. And if you got all the way through this, good for you. I appreciate the time and listening to me drone on. Take care.